Alright, hello and welcome back to another one of my video log recording sessions where I talk about genetic algorithms and all my screw-ups, and then where I feel so out of my league and just really stretched thin, where my intelligence feels so stretched thin. I don't know if I'll be able to do this, but it's just another Monday, or Tuesday rather, as the date is 2025 April 1st, so it is actually a Fool's Day. However, the irony is that what I have found out today is not a joke, as in it is all real. I have just realized that the work I've been doing, or I have done for the last 2 to 3 days, have been almost in vain. So that's a huge letdown, and I wish it were an April Fool's joke, but it is not. So with that out of the way, having said that, we'll continue. So in my last recording, I finished by stating that I need to find out if I could just if I should generate item 1 to all the way to item n, and then also generate util values and constraint values for for the iterations, and because so far what I did was generate these values and fix them, and then do it for a number of iterations, 5, for example, 5 or 10 I could do anyway, and then they would all show different results, whatever, something like this, and at the end of my last video I said, why not, if I were going to iterate it for, like, for example, 5 times, why don't I generate these values per iteration? Yeah, and see if the patterns or behaviors change. That's what I did. But today I found out that there's something I missed, because in my last video, anyone who cared enough to watch it, in the 7 notebooks that I created, I only ended up plotting the dip percentage values against the max constraint percentage values, and here were the results. And then I said, oh, as the maximum constraint percentage goes up, the dip size percentage, the average dip percentage also goes down. Then I thought maybe it was, it's obvious, because now as the max constraint percentage goes higher, all the way up to 1, you can have every item or every gene activated and not go above the physical weight threshold, not go above the maximum constraint threshold, and therefore the top entities will just kind of stay there, and therefore the top entities get to stay there, and then the average of top 10% entities should also rise and be very close and never kind of dip. Well, it turns out that it wasn't actually the case, and I'm going to go through all of the results in this video for the first time. And for some people it will be funny, because I'll be ranting, and I'll be ranting about how short-sighted I was. So the first notebook, general genetic algorithm grid search for normal distribution, 0 for the indicating this is kind of the first version of this. I plotted the values of top entities, and I also plotted the values for the average of top 10% entities. So here's what happened to the head. I remember the total utility value, the total sum of utility values in this case, in this notebook, is 9,990.83 something. So the top should be there. So here we go. At 5%, at 10%, max constraint percentage, at 5%, 10%, 15%, 20%, 25%, 30%, 35%, 40%, 45%, 50%, 55%, 60%, 65%, 70%, 75%, 80%, 85%, 90%, 95%, and 100%. And as I said, the total sum of all utility values is 9,900 point something, and these are the values for the top entities. And you'll see that none of them actually reached the 9,000 mark. They're only at 7,000. None of them. So, for example, this is okay at when the maximum constraint percentage is at 70%, which puts the top entity, the top of the top entity, the highest possible, at 7,000. So some have reached that. Some, in some evolution phases, we have that. At 75%, we don't have that. At 80%, we don't have that. There should be, some values should be all the way up at 8,000, nowhere close. Again, 85%, nowhere close. 90%, nowhere close. 95%, nowhere close. 100%, where the top entity, the best entity that could ever happen possibly, should be 9,908.3.38 or 8.83 or something. It didn't happen. It never happened. Why? So I move on to the plots for the top 10% of the entities. And here are the plots for the maximum constraint when it's at 0.05 or 5%, 1%, 15%, and I mean 10%, 15%, 20%, 25%, 30%, 35%, 40%, 45%, 50%, 55%, 60%. Now, yeah, well, okay, that's actually fine. No, we're fine. 55%, 60%, 65%, 70%, 75%, 80%, 85%, 90%, 95%, and 100%. And then yesterday I would have just said, oh, nothing unusual here, as the dips don't happen because now the entities can actually contain everything, almost everything, at 95% or 100%. But if you look closely, the plateau in this case is at around 6,000. But so are they at when the max constraint risk percentage is at 95%. 90%, it's also, the plateau is also at 6,000. 85%, still at 6,000. We're going backwards right now. 80%, still at 6,000. 75%, still at 6,000. 70%, the dips happen. And this is when, this plot is when this happened at 70%. We had this, and then it went back down. And then yesterday, in my last video, I said, oh, the dips didn't happen, because now the entities could actually contain everything. Well, it turns out, look at that. The dips did happen. And here at 70%, the dips did happen. But when the max constraint percentage went from 70% to 75%, the plateau is still at 6,000. And this, for when max constraint percentage is at 70%, the plateau is still at 6,000. So theoretically, there's no, well, for now, on the surface, I know why. I think I kind of know why, but on the surface, we should have a dip, and then it just, or we should have the plateau at a higher level, because there's actually nothing, because we would think that there's nothing stopping the entities stopping the entities from being struck out because of the threshold. Well, let's have a look at the top values when at 75. At 75, it never happened. The top entity, or the top entities per generation, some of them should have reached 7,500, and it never happened. Never. And so when we go to the plots for the top 10% over here, that also didn't happen. The plateau is still at 6,000. However, it did peak over here at 65% or 70%. It did peak. So we look at another notebook for the log normal, hoping that maybe this is different. Spoiler, it is not. No, it's not. Again, these are the plots for the head or the top entities, and the total sum of utility values is 3,405. So we'll just cut to the chase and look at when the maximum constraint percentage is at, go away, at 100%. The top values never reached 3,400. Not here, not here. It never reached it. Maybe here, we got lucky. Here, we also got lucky. But then again, yeah. So let's have a look at the plots for the top 10%. At 65%, there was a peak, and then we have a plateau. We have plateaus for each iteration. At 70%, same thing. Peaking at around, the average is peaking at around slightly below 2,500. At 75%, again 2,500, and then we plateau at around 2,100. At 80%, we do peak, but we still plateau. At 85%, no peak whatsoever, and the plateaus are all around 2,100, which is odd, because that's not supposed to happen. This plateau is supposed to be higher. Same here, at around 2,100. Something's wrong. It never happened. The peak, these occurrences never happened. At 85%, didn't happen. 90%, did not happen. 95% didn't happen. 100% did not happen. So almost the same behaviors when we look at the log normal distributions. And remember the notebooks that I am dealing with today in this session are all using the same distribution for the utility values and the constraint values. Of course, in the future I need to do a combination, so that just means more work, a lot of time running the scripts. And now we're using the values sampled from uniform distribution. Yeah, and the total sum of utility values is 51 in this case. So at around when the max constraint percentage is at around 100%, we should have 51. It never happened. Nothing ever hit that. They're all below 40. Same here, same here, same at 85, same at 80%. Something did happen, but we plateaued downwards. Yeah, and we have a look at the plots for the top 10%. Let's just jump right to at around 65%. Yeah, 60%. We do have slightly some bit of a peak and then it plateaus. 65%, we do have peaks and then it plateaus at around 30. At 70%, similar, very similar plateau peaks and then plateaus at around 30. At 75%, peaks and then plateaus. Sure, at around 30 again. At 80, we have no peaks and the plateau just sits at 30 with no peaks. At 85, same. At 90, same. At 95, same. At 100%, same. All plateaus being at around 30, when I thought the plateaus could be higher. Exponential distribution. And then we look at that. The total sum of the utility values is 60.88. And then we look at the heads or the top entities, and then we go straight to where we have the maximum constraint percentage at 75%, 80%, 85%, 90%, and some of them were supposed to hit 60. Nothing did. It never did, ever. And onto the averages of top 10% entities. We go there, and then at around maximum constraint percentage 50%. Yeah, that's what happens. 55%. That's what happens. 60%. It wobbles. It oscillates. Yeah. 65%. Now we have some peaks, and then we have a plateau. Even something more funny, something funnier, or even more, weird, is that at maximum constraint percentage 60%, the plateau is above 40. However, when the max constraint percentage is at 65%, the peaks are above 40, and then the plateaus are slightly below 40. I thought they'd be higher. They're not. At 70%, again, same. At 75%, the peaks happen, the plateaus happen, but the plateaus are still at below 40. At 80%, the peaks do happen, but the plateaus are still below 40. At 85%, the peaks never happened. They just plateau. At 90%, same. 95%, same. 100%, same. And it's the same thing. I don't want to. It's the same thing. When I use the von Mises distribution, where the total sum of the utility values is 257. Keep that in mind, 257, and some of the top entities were supposed to reach that mark, 257. They never did. They never did. Not even close. None of them did. Never, ever. And plots for top 10%, and then we jump straight to max constraint percentage, 50%, 55%, 60%. Now we got some peaks, and then whatever, and then 65%. Now we have some peaks, and then we have a nice plateau at 160 or something. At 70%, still at 160, we do have some peaks. At 75%, we do have the plateau at about 160, and we do have some peaks, but at different times. And then at 80, we do have plateaus, but no peaks whatsoever. At 85%, no peaks, just plateau at the same level. At 90, 95, 100, same level. Same story when I use the Pareto, where the total sum of utility values is 159, so 160, let's just say. And then did that ever happen? No, it didn't. It did not happen. It's supposed to. I thought it was supposed to, but apparently not right now. And the top 10%, the average of top 10%, go there, and then we have plateaus happening at around 100, still at 100 when it's at 70%. The peaks happen above 100 and then they fall back down. At 75%, no peaks. 80%, no peaks. At 85%, no peaks. 90%, no peaks. And the plateaus are slightly below 100, or let's just say 100. Never happened. Never. And Weibull, whatever. Same. Total sum of utility values is 99.21. So at 100%, maximum constraint percentage, at 100%, I am supposed to have some values reaching 99. I don't have that. None of them did. At best, it's 80. So for the top 10%, average of top 10%, at 55% we do have some oscillations, and then at 60% we do have some kind of peaks and then plateaus at around 60 or slightly above 60, and then at 65% a peak, some peaks below 70, maybe 66 or 67, but the plateaus are at around 60. At 70%, same story, peaking all the way up to slightly less than 70, and then back down to plateauing at about 60. And at maximum constraint percentage 75%, we do have peaks at different times, but eventually they all come back down to plateauing at around 60. At 80, no peaks, just plateauing at 60. At 85, same story. At 90%, same story. At 95, same story. At 100%, same story. No peaks. So what's happening? Well, one thing, I think this is what, and one theory is that let's just yeah. So I think this is what might be happening. So when I have, I'm just gonna show, yeah, maybe blue, no purple, no red, I'll just use yellow, orange, no red is good. So when the evolutions happen over time or over generations, they all happen fine up until about here. here at the 50 or 60 or 70. And this is just by mutation. And then with up to here, it's about, regardless of the maximum constraint percentage, this is mutation plus procreate function, or parent selection procreate. But then again, if the maximum constraint percentage is probably at like 65%, what happens is that is at 65%, and some entities will be struck out by, and then new ones will be made. But, well, new ones will be created from the ones that remain. And through this procreation, new innovations come, most of new innovations. New entities that will take up the that will be among the top 10%. So that's when let's just take this for example. So through procreation, mostly through procreation, that's when these happen. These sharp, very steep increases. Or these are the plots for the top 10%, but more intuitive one. Oops. So when some of them get struck out and new entities need to be introduced or made, or made through procreation from remaining entities by some form of by some way of through some procreate function, that's when these happen. These big ones, these big jumps. These were the top entities or heads, the values for the heads. That's when these happen, these huge jumps. Of course, some remaining entity or entities, some remaining entities also could procreate. Would be able to procreate these entities that make them, these entities with higher than before total sum of utility values. And of course, some remaining entities could mutate to become one of these. But that's, maybe not so likely. I don't know. I still have to do my work by combing through all the entities, through all the generations to find that out. But anyway, so that's how it works. The max constraint percentage strikes out some of the entities and then makes room for new entities to be created through procreation, and then these jumps happen. So when or if the max constraint percentage is high, 100%, well, so far the way I'm doing this does not ensure the introduction of these new ones, because I'm not actually striking anything out. And the selector function, the selector is not actually selecting anything, because everything just goes. So what happens is this. This is what happens. Nothing is being taken out, and all we can do is just mutate through. That's what happened. So I would need to find a way to ensure that or maybe I would need to decide whether I would need to find a way to ensure that jumps happen even when max constraint percentage is high, for example above 90 or above 85%. Or how to whether I need that or not, and how to ensure it, whether I need that or not, and if so, how to ensure that would happen. Yeah, that's what I need to do. And then work on decide whether I need to do this, generate new values per iteration. So that's what happened yesterday, and that's what I missed in my last video, and I am disappointed in myself that I didn't see that. I was just too focused on running the script and getting these plots out, when in actual fact I could have just I should have plotted everything, and then so that the information that I get from this would complement the findings that I have, that I would get from here. I didn't, so therefore I had to do this more work. So that's why I am frustrated, or kind of disappointed in myself. I'm so short-sighted. I didn't know that would happen. So what do I do? Yeah. So and also, while I'm doing that, I would need to I know there are ways of doing this, about what I'm about to say, but I would need to find out how I can calculate plateaus. Yeah, for example, for this one and this one, the plateaus are easy. Just average these. But what am I going to do with this? This one. Where am I going to average it? It's like, suppose I'm following the purple line. I follow the purple line, and then I go up here, and I come down here, and then it stays there. So the slope is basically 0. And when this is detected, I would call that the plateau. But these, in this case, they happened at such different generations. Look, this is 170 or 80. This is 220. This is 260. This is around slightly more after 300, and this is after generation 400. So how do I know this? I would need to continuously just see this. or yeah, I would have the values stored in the result list top 10%, but given the list of results, find out the plateau, find out how to calculate the plateau, how to pinpoint the plateau. Because if I'm given something like for the top 10%, this, or this, or this, these would be fairly easy. Like this, for instance. Look, for this one, the plateau is easy. Average this. Easy. For this one, not so easy. Well, it is easy because I could just average this too, you know. So average things from generation 300 to generation 500, you know, easy. But then again, just look how different the peak generation is. Very different. Look at this. For instance, like, see the difference here and here? These are also very different. The peaks happened at around the same time, whereas when the max constraint percentage is at 0.75%, this is the exponential distribution. The peaks happened at, you know, different times, but it's still before generation 200. But when the max constraint percentage is at 0.8 or 80%, look what happened. One happened here after generation 200. One happened here at 260, maybe. One happened here when it's at 370 or so. And then something happened at generation... For the purple line, the peak was happening, and then everything just ended. So I can't average the loss. This is included. These two peaks, or this one peak and this one would-be peak, are included. So if I'm to average it, the average would go up. That's disappointing. So how do I get this? Yeah. How do I get this? So maybe I could just... No, I should have ended this video about 10 minutes ago, but I'm just going to say this. Maybe as I go through the result list, top 10%, I could be calculating the moving average, and then settle with averages that kind of come back. For example, for the orange line, the average was at around slightly below 40, 39 or 38, let's just say, and then it goes up and then comes back down, and then when it comes back down, it's back to 38. And if this continues for some time, we'll just say this is the plateau. But for the purple line, this is continuing. And then it goes up. So that kind of never happened. So how do I know this? See, for these are easy because the slope did increase, and then it decreased, and then it stayed the same. So when that happens, we know for sure that it is a plateau. At least we kind of know for sure. But when the slope never actually happens, I mean, the slope did go increase up until here, and that's what we're talking about. The slope goes up, 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 and then it becomes 0, and then it goes up again, plus, and then it becomes a minus. So the slope is plus first, and then 0, well, you know, at around 0, approximately 0, and then it's a plus again, and then it's minus for this bit, and then it's 0. So this is a plateau. But suppose this happens for the red line. It's all plus here, plus, plus, and then the slope never hit 0. It just shot up. It just shoots up. So it's still a bigger plus. Well, kind of. Well, not bigger, because the slopes are always the biggest around here. But it is still, you know, just as big, this bit. And then the slope is minus, and then it's a 0. So that's a plateau. Plateau. So I need to find a way to find plateaus given this data. I don't know. Well, I will need to do some research into that. Yep. However, this is still disappointing. I mean, it's not disappointing itself. It's disappointing that I didn't see this. That's why it's disappointing. These behaviors, these characteristics or behaviors are just in of themselves just maybe how it's supposed to be. So it's not such bad news. So that's that. Thanks for watching. Goodbye.